if folks, sorry, I was a little late to get it started. So we'll also be putting up a video of the recording so that you can share that with colleagues and such. If you're having difficulty listening to the audio or your internet connection's unstable, you can also call in and participate via your phone. The phone number was provided in the constant contact invitation that went out, so you have access to it there. And also for the Q&A session that we're going to have following the presentation, we recommend that you use the Q&A box to enter your questions and not the chat box. Using the Q&A box just helps everything run a little bit smoother. And plus, it'll also allow us to sort of have a copy of recording of all the questions that are asked in case we need them for any future use. So again, please use the Q&A box to submit your questions. Also, you can also ask a verbal question by raising your hand. And let me put up a screenshot of where you can find that. Let's see here. Where is my, here we go. Where is, right, here we go. Okay, perfect. Oh, sorry, I got the wrong one. Sorry, excuse me. Here. Yes, sorry. If you see here on the screen, on my screen, right where your name's at, you can click on the raise your hand and it will recognize you and then you can proceed to ask your question. We will unmute you, but you'll also have to unmute yourself so you can ask your question. And once again, here's the dial-in number in case you're having trouble with your internet connection. And so again, please submit your questions into the Q&A box, and then we'll be able to answer your questions once we're done with the presentation. And with that,
Jose, that wasn't the screen share you were planning.
It's not sharing?
It's sharing your email inbox.
That's strange. Okay. Okay. On my end, it shows that it's sharing.
It's sharing, but it's sharing your email inbox. Sorry about that.
Oh, sorry. Let me see if I can. That was odd. Okay, let me do that one more time. Checklist of items. Oh, here we go. Sorry. Found it. Okay. Is it visible now?
Yes.
Okay. Okay. So as you can see here by your name, you'll see the hand when you can raise your hand. Down at the bottom, you have the Q&A box where you can click on and then submit your question via the Q&A box. And over to the left, we have the dial number in case anyone's having any issues there. So, okay. And with that, I will turn it back over to Lisa. Thank you.
Okay, thank you, Jose. I hear my son singing in the background, so forgive the background noise. So I'd like to introduce our three presenters. The first is Jonathan Stead. He's a fish and wildlife biologist and project manager with expertise in fish passage, steelhead biology, and aquatic ecology. At AECOM, he currently leads multidisciplinary teams on complex stream restoration, fish passage, dam removal, and water infrastructure projects, and has been a major contributor to important stream projects around California. So welcome, Jonathan. Next, we have Michael Lev, who is the managing principal of Michael Lev and Associates. He is a professional engineer with extensive experience in fisheries, fluvial geomorphology, stream restoration, and fish passage. He led the development of the widely used fish crossing software and the fish passage assessment, design, and implementation sections of CDFW's California Salmonid Stream Habitat Restoration Manual. So true expert. So happy that you're here, Michael. And finally, our third presenter is our very own Kevin Sibley, Senior Engineer with Valley Water's Water Resources Planning and Policy Unit. Kevin will speak to the next steps of moving from this study to identifying potential future projects to address the passage barriers. John, Michael, and Kevin, the floor.
Thank you very much, Lisa. And thanks to Valley Water for hosting us, and to all of you for joining. Michael Love and I are going to be co-presenting today. We get the presentation up. Okay. Somebody give me a nod. Is everybody seeing the title slide of the presentation? Thank you. Great. So Mike and I are going to be presenting the results. Actually, we're going to go quite a bit into the methods and a little bit into the results, but you can get the results from the report online. But methods and results from our Stevens Creek fish passage analysis. We're going to, after this brief introduction, we'll talk about some field reconnaissance that was done up and down Stevens Creek. That led to the assessment site surveys, our field surveys, collecting the information that we used to do the fish passage assessment. After the assessment methods, we'll be talking about our scoring methods. We developed a unique scoring equation that allowed us to quantitatively compare the assessment results. Then we'll have a bit of a discussion which follows the discussion section of our report. What we're going to point out are several factors that are important when prioritizing barriers for remediation that are not captured in the strictly quantitative analysis that is presented in today's presentation and in the report. Then we'll hand it over to Valley Water to talk about next steps. And then we'll circle back to do some question and answer. So we'll have plenty of time at the end for both Mike, myself, Kevin, and others at Valley Water to answer questions. So a little background information. Valley Water and other stakeholders have been working to recover steelhead in Stevens Creek since the 1990s. In 2004, Valley Water's consultant completed a limiting factors analysis. That's a study that looked at the factors that would limit steelhead recovery in Stevens Creek. And one of the major findings was that fish passage, or the presence of a number of passage impediments in Stevens Creek, were a key limiting factor to steelhead recovery. But the study wasn't comprehensive in terms of identifying or characterizing the passage impediments, nor was it quantitative in terms of how severe the effects of the impediments and barriers were. So it led to reconnaissance. Valley Water and other stakeholders conducted a bunch of reconnaissance in Stevens Creek to identify the location of the passage impediments and enter them into the California Fish Passage Assessment Database. And that's all prior to when Michael Love Associates and AECOM got involved. We got started in 2018 with a list of pre-identified sites potentially affecting fish passage for further investigation. Two of those sites were evaluated in 2016 by Mike and his firm. And that was great. It was a neat little study that we were able to leverage and apply similar methods to this much larger study. The primary objective of the study is to quantify passage opportunities at all of the impediments in Stevens Creek downstream of Stevens Creek Dam. We looked at the degree to which the impediments limit passage for adult and juvenile steelhead separately. And then we also looked at the position of each assessment site in the watershed, which is important when you're thinking about a strategy to improve passage up and down the creek. And also we looked at the distance to the next upstream barrier from each assessment site. So if one site was remediated, how much habitat would that open up above it before a fish would encounter another barrier? And all of this information was developed for Valley Water and other stakeholders to use when prioritizing barriers for removal or remediation. So in summary, we're really going to focus on our quantitative analysis today. We'll also talk about some additional considerations which were not the focus of our analysis, but are important for the pending or ongoing now prioritization. I really like these maps you can get online from the Oakland Museum of California. You can actually get these for a number of local watersheds. But I wanted to illustrate some of the changes, kind of basically give you an overview of Stevens Creek and also some of the changes that have occurred in the creek over time. So on the left, you can see the pre-settlement Stevens Creek starting up here in the Santa Cruz Mountains, flowing down into the flats on its way to San Francisco Bay. And what you see is the creek is not, the streamline is not continuous to the bay, and it's typical of the historical condition of a lot of our Central California streams, where when they hit the alluvial flats, the streams, often entered a complicated network of braided channels or flowed through marshes and maybe didn't maintain a distinct flow path all the time. And that's why you see the stream petering out and branching before it hits the bay. Of course, that condition is not compatible with the, the high level of development around the bay now. So you see these modifications. Well, first we have the reservoir here, which marks the upstream end of our study area. And then you can also see the channelization of this and other streams into these engineered channels that carry the flow more reliably to the bay so that it doesn't flood the infrastructure. Another change that's important for our analysis is this cross watershed diversion from Permanente Creek. The reason that's important is because we need to consider hydrology for this analysis, and it differs upstream of that point of diversion or the outlet of that diversion right here on Stevens Creek than it does downstream. So this map shows the 34 pre-identified sites that we started off with, mostly from the California Fish Passage Assessment Database and prior reconnaissance. So each yellow dot is a site that we set out to investigate. Beginning with our field reconnaissance, which we used to refine the list of assessment sites. We went out to each of the 34 pre-identified sites and visited them to confirm that they were still present. Some of these sites may have been modified or removed since they were initially entered into the passage assessment database or observed by stakeholders. So if we did confirm the presence of a fish passage impediment, then it became an assessment site, at which point we did a plan view sketch with a focus on hydraulic features that we would capture during our topographic survey. And also another focus of that was the channel conditions along the bed and banks that would inform our roughness values that were used in the modeling equations. And we also did our own reconnaissance. This slide shows just a section of the study reach. And what I wanted to highlight here is the AECOM MLA team's reconnaissance is shown in this slide in green, and the reconnaissance conducted by Valley Water in purple. And what you see is actually quite a bit of overlap. So this is the same up and down the entire study reach from the dam to the bay. It's about 12.8 miles. And so with this level of reconnaissance, we have a high degree of confidence that we captured all of the fish passage impediments, I should say the man-made fish passage impediments in Stevens Creek, because we didn't investigate anything like critical riffles. And there aren't a lot of falls or cascades or anything like that in this reach below the dam. So we have a high degree of confidence in that this study captured all of the passage impediments, making the analysis fairly comprehensive. In the end, we confirmed the presence of 25 of the pre-identified sites. We dropped some sites that weren't present anymore. We added some new sites and ended up with 30 sites that were assessed for this study. With that, I'm going to hand it over to Mike, and he is going to walk you through the next set of our methods and results. Uh-oh. I'm actually not seeing Mike. Did Mike disappear? Jose, do you need to let Mike back in?
He may have, Mike may have dropped off.
Dropped off. Yeah, I don't see him as an attendee for me to move him over. So.
Uh-oh. His computer crashed. That's really disappointing.
Oh.
Oh,
wait, here. Here. Over.
Maybe a restart. I can walk through Mike's slides, but not as well as you can.
Here he is.
Great. Mike, it looks like you're rejoining us now, and just in time for the handoff.
Can you hear me, John?
Yeah, you're rejoining just in time for the handoff.
Yes.
On slide 11.
Okay. What strange thing to have crash right there.
We didn't practice that.
Let me get the screen sharing going. Sorry, everyone.
We're seeing your, there you go.
Okay. Oh, I'm sorry, I gotta jump to this right slide here. All right, sorry about that, everyone, but hopefully we get back on track here. So I'm gonna take over from John here to talk about the first these site assessments, and then go into quite a bit of detail on the quantitative analysis that we did of each site. So in terms of the site assessments, as part of that reconnaissance level walkthrough and identifying all the sites that exist, we also looked at how they were kind of grouped together, and we put sites into reaches. Some of the sites had some of the reaches had just one site, such as reach 1. Reach 2 had 2 sites. And then, for example, reach 3 had 8 sites, as they were all lined up together. This made the analysis a little bit more efficient for the hydraulics that I'll show later, but it also allowed us to look at the effects of one site on the conditions, passage conditions at an adjacent site, which at several of the locations that was the case. Once we got our reaches together, we went out into the field. First thing we did was we completed what we called the first pass data sheet, which is a data form that describes the type of barrier or type of potential impediment, some dimensions, locations, and it's a data sheet prepared by CDFW and is used to enter information into the passage assessment database that the state maintains. Then we surveyed with doing a topographic survey with a total station, a piece of equipment, and we surveyed first of all, longitudinal profiles down the stream of the Thalweg. That's the deepest point in the channel at any location. And then we surveyed numerous cross sections. That's surveying the ground across the channel from one bank to the next. We did those on the structures that we were focused on, as well as at pools and at hydraulic controls such as riffles. We also documented what the substrate was and what type of vegetation there was on the banks. And we used that later on, as you'll see, to quantify the hydraulic resistance or roughness that the channel has, which affects fish passage. So I'm going to show you here an example of our profile from reach 14. This reach has 3 sites in it, and to give you an idea what they look like, turn on my laser, but this is site 33, 33.1, and 28. The first one is a failing old flashboard dam on the left. The center is what we call sackcrete, sacks of concrete stacked up to make a trapezoidal channel. And the one on the right is a large arch culvert with a broad gravel bedded bottom. So this gives us a Thalweg profile showing us the channel slope through that reach. And then at each dot there, where it has an XS, that's a location that we took a cross section. And you'll see how we use those for our hydraulic analysis. So once we were done with our field work, the first step was following the Cal Fish and Wildlife passage assessment protocols. We put the sites into a filter. And this filter is intended to identify those sites that are green, that are automatically can be identified as not a barrier to adult and juvenile steelhead. It Also looks for those that we call red or failing to meet passage criteria, assessment criteria at all passage flows for adults and juveniles, and then the ones that are gray, which are indeterminate, that are going to need more analysis to really determine how much of a passage impediment the site is. And what that filter is essentially a flow chart. Now, the protocols developed by CDFW and the flow chart here you'll see was originally developed specifically for culvert crossings. Now, we do have some culvert crossings on Stevens Creek, but a lot of it, we have a lot of other types of passage impediments that we are focused on. So like many others, we've adapted a lot of this protocols for use on all types of passage structures that we're evaluating passage. So here, the first question of this, if we start and run through site 9, which is a concrete drop structure upstream of Middlefield Road, we ask, is there substrate through the culvert or through the drop structure? No, it's concrete. And the next question is there a residual inlet and outlet depth greater than 1/2 foot? What that's asking is at very low flows, such as this photo, is there water backwatering over the structure and making at least 1/2 foot of depth of water? And we can see that's no, because it's sheet flowing off the structure there. So we go to the next question, is the drop greater than 2 feet? No, at this flow, it's about less than 2 feet and about 1 foot. So then we go to the next question, is the slope of the structure greater than 3%? It's kind of a threshold for velocities and depths. And the answer here is no, it's relatively flat. So this structure falls into the gray category. So all the sites that were gray, as well as those ones that are red, we did an in-depth passage assessment, a quantitative assessment, as you'll see. We did have one site that was green. This site is the Fremont Avenue crossing, and it's wider than the active channel upstream and downstream of the crossing. It has substrate, gravel substrate through it, and it has a residual depth of at least 1/2 foot through the entire structure. As you can see here, there's a decent pathway that fish could swim through even at lowest flows. So all the other ones, the reds and the grays, we did a more in-depth analysis. And in order to do that, we needed to know what flows we were going to analyze fish passage, because we don't expect to provide passage for fish at very low flows when the natural stream channel is actually too shallow for fish to move around. And we don't expect to pass fish, juveniles and adults at very high flows, such as a flood or maybe a 2-year or a bank full flow, when the fish are kind of holding and waiting for the flows to recede and the velocities and turbulence to drop before they move upstream. So so what we need to define is a range of flows that we're going to evaluate, that we should be providing passage throughout that range. And CDFW, Cal Fish and Wildlife, and National Marine Fisheries Service, NIMS, both have prescribed how to develop those assessment flows. And they have the same methodology and requirements and criteria. So they are based on daily average flows in the stream. And for adult steelhead, they define it as the median flow or the 50% exceedance flow. So that's the flow that half the time it's less in the stream and half the time that's more in the stream. Or if that flow is less than 3 cubic feet per second, we use 3 cubic feet per second. The high passage flow is 1% exceedance flow. So 1% of the time during the year, the flows can be higher than the high passage flow, which is about 3.6 days a year. Juveniles also have a passage range here, which, as you can see, is a much lower flow, or usually 1 CFS, cubic feet per second for the low end, and then 10% exceedance flow for the high passage flow, which is about 36 days a year. The flow would be higher than that. So we needed some flow data, and thankfully Stevens Creek, thanks to Valley Water, has a really good record. There's 2 stream gauges on Stevens Creek. One is SF44, just downstream of the reservoir. And then another one is SF35, which is downstream of that Permanente Creek diversion that John talked about. So the hydrology changes downstream of that diversion. So sites downstream of the diversion used SF35 and those upstream used SF44. So doing the calculations, this is the range of flows we got for those 2 groups of sites. So for example, sites 1 through 19 downstream of the diversion, the high passage or the low and high passage flow for adults is between 3 CFS and 203 CFS. And you can see the rest for the other adults at the other sites and for the juveniles. So what does that look like when we look at a hydrograph or flows in the stream? So here's dates on the horizontal axis during the typical migration season for adult steelhead from December through April, and flows in cubic feet per second on the vertical axes. And we have the two different stream gauges here. And the horizontal dashed lines are the low and high fish passage flows. So we expect to have a structure that's going to be what we call 100% passable to be meeting criteria between these two dashed lines. When we have flows that are greater than that, such as during this one event in December, we can expect to have flow conditions may be not meeting criteria, and we still are meeting passage goals for the site. So now we have our flows. The next is to look at what is the hydraulic environment the fish are going to encounter as they try to pass through each one of these sites. So that required some hydraulic analysis or hydraulic modeling. And what we used was a model called HEC-RAS or HEC-RAS, which is a 1D steady state model for open channel flow. It's kind of state of the practice to use RAS for fish passage assessments, as well as many other uses, and it's developed by the U.S. Army Corps of Engineers. There's 15 reaches, so we developed 15 different models, many of them having multiple sites within a reach. The geometry of that model was based on all those cross sections we surveyed, and the resistance to flow, or what we call the roughness coefficients used in the model, were based on our observations of substrate and vegetation and using a standardized procedure to come up with those coefficients. Besides using HEC-RAS, three sites required some additional analysis. Two of them were ones that had Daniil fish ladders on them at Moffett fish ladders, as it's often called, and the Fremont fish ladder. Those we used standardized fishway equations for Daniil fish ladders. The other site was one site that had a very large boulder channel that had been constructed, and so we used some equations to analyze the roughness of those boulders and how that provided passage or not. So with that, some results of the model. This is what one of the results out of the HEC-RAS model looks like. This is that same reach we looked at with distance from downstream to upstream on the horizontal axis in feet and elevation on the vertical axis, and the black line being the profile of the channel. The blue filled in areas is the low passage flow through this reach, and the blue triangles is the high passage flow for this reach. What this helps us with is analyzing where fish need to leap, if they need to leap, and how high that leap is that they need to get over the structure. We also can then, if they have to leap, look at how deep the pools are and make sure they're deep enough to provide depth for leaping. And so to remember what those three structures look like. This is that failing drop structure, flashboard dam. This is the Sac Creek trapezoidal channel and that arch culvert with gravel bed. And we can see that there is a drop here at that lower one that had to be analyzed for leaping. Other types of results that the model gives us is water velocities. Once again, we have stationing or distance from downstream to upstream on the horizontal axis. And on the top graph, we have velocity in feet per second. And then on the bottom one, we have channel depth or water depth in the channel in feet. And so at each of the sites, as they're highlighted in blue here, we could look at the velocities, the cross-sectional average water velocities, and the maximum water depths the fish was encountering if it swims through the site at a given flow. So we ran the model for many, many flows to look at what the passage conditions were over a wide range of fish passage assessment flows. So then with all that data, we could then do our fish passage assessment, the last step of that, which is the fish routing model. So we need to see what the fish can swim through now that we know the hydraulics that they're going to encounter. To do that, we needed some passage assessment criteria. So this assessment criteria came from that Cal Fish and Wildlife Fish Passage Assessment Manual, their protocol. These values were originally, like I said, were for culverts, and they were used to put into the fish crossing software, which was used to analyze passage through the culverts. We had to do a little bit of adaptation to these criteria to work with the HEC-RAS model. So what are the criteria? There's water depths, so minimum water depths. There's swim speeds and times to exhaustion for prolonged, or that's kind of jogging speed for fish, and burst or sprinting speed for fish. And then maximum water surface drop, and looking if they had to leap, is the pool deep enough? There were two places we had to make a small modifications to these criteria. One was the maximum water surface drop. We used, as you can see, 1.5 feet instead of using criteria that were based on leaping speeds of fish that is input for fish crossing software. The other was that we modified the minimum water depth criteria from 0.8 feet down to 0.7 feet for adult steelhead to be consistent with Valley Water's criteria for critical riffles in Stevens Creek. And otherwise, the criteria remained the same. So like I said, all this used to go, or when you assess culverts, goes into the fish crossing software. I want to show you kind of what the output of that software is, so you can get a sense of what we were trying to basically replicate in our analysis. So here is a culvert at a specific flow. You can see the fish down there in the pool, and you can see that the software is telling us that we have excessive leap at the outlet and insufficient or shallow pool for the leap. We also have, if the fish was able to get in there, too fast of water, and they become exhausted, and much of the culvert is insufficient depth at this specific flow. So we took the same algorithms that were in fish crossing and basically made a spreadsheet model that took the HEC-RAS results and then determined if the fish could make it. So what that entailed was at a specific flow, we ran the HEC-RAS model, took that output and put it into our fish routing model. And then it told us whether we had successful passage at that flow or whether we had not meeting passage criteria. And if we did not meet passage criteria, it would tell us where we weren't meeting criteria and what kind of criteria we weren't satisfying, including excessive velocities and exhaustion, insufficient water depths, excessive water surface drops for leaping, and if they had to leap, insufficient pool depth were the types of criteria that it was evaluating. So now for the how we put together the results, we ran a number of flows between the low and high passage flow and identified the range of flows that meet passage criteria. So those are the passable flows. And then to determine the percent passage, we took the passable flows and divided them by the entire flow range that we were analyzing. That's the high fish passage flow minus the low fish passage flow. And then we multiplied that ratio by 100 to get a percent. So those sites that were had no passage, they were 0% passable, as we'd call them. And those sites that were fully passable at all passage flows were 100% passable. And then the remaining ones we called temporal barriers, and they had a passable passage percentage between somewhere above 0 and below 100. And we did this both for adults and juvenile steelhead. So to kind of help you understand what that looks like when you look at flows in a site. So for example, here we are looking at site 17.1, which is a Sac Creek concrete drop structure intended to hold some grade in the channel during obviously summer flow, low flow or no flow in this case. And here we have the hydrograph from the gauge for one of the years in 2017 during the steelhead migration season. And our analysis found that up to about 33 CFS, we had insufficient depth over this structure. From 34 up to about 89 CFS, or 28% of our flow range, we met criteria. And then above 90 CFS and greater, we had excessive velocities for adult steelhead. So this site was considered 28% passable. I did forget to mention one thing about our criteria, which I think is an important thing to mention, is they're based on the entire population of steelhead and not like the strongest individuals, but often actually kind of leaning towards the weaker individuals. So when we say something's a barrier, we're basically it's not meeting those criteria, but we don't say that all fish wouldn't be able to pass, because there are going to be stronger individuals, for example, or those that swim with their backs out of the water, et cetera, that are maybe going to make it past this structure at a flow that we are calling a barrier. But in general, the majority of the population of the steelhead would not be able to make it if we're not meeting criteria. So with that said, here's a kind of how it looks in terms of a sample of our results table, where we have the site number, name, and river mile. And then we give the range of flows meeting criteria, for example, 57 to 203 CFS on this site here, site 1, or 70% of the flow range for adult steelhead. And we give the same for juveniles, where we, in this case, we have no flows meeting passage criteria. So in total, we had for adult steelhead, out of our 30 sites, we had 1 that was green that I already mentioned. 3 sites were complete barriers, not meeting criteria at any of our passage flows. And 26 of the sites were temporal barriers or partial passage. Juveniles kind of had that green site, and then we're kind of the flip of adults, where we had 26 sites that were complete barriers and 3 sites that were temporal barriers. And to give you a visual of what these kind of sites look like, we have the drop structure on the left, bottom left there. That was considered, came out as not meeting criteria for both adult and juvenile steelhead at all flows that we assessed. And the site on the right is a temporal barrier, where it takes a significant amount of flow to get enough depth over that old concrete sill there to get the fish up. So then the last thing that we looked at is kind of looking at all the sites together in continuity of the stream reach. So this is all the sites lined up from left to right, is from downstream to upstream with the site number and the river mile. And then we have a flow in cubic feet per second in the vertical axis. And the dashed lines are the low and high fish passage assessment flows for each site. And the blue columns are the flows meeting criteria, and the red columns, portions of the column, are those flows that are not meeting criteria. So we can look at what it takes to get a fish upstream. So for example, let's say that we remediate the passage issues at sites 2 here and site 6 here. So now a fish coming in from the bay at 150 cubic feet per second flow in Stevens Creek could swim all the way upstream, probably fairly quickly, until finally it gets to site 12. At site 12 at 150 CFS, it's not meeting criteria, and the fish is likely going to keep attempting to get through that site until the flows drop and conditions improve. So it would have to sit there maybe until the flows in the stream drop to 90 cubic feet per second before it can move on upstream. And so that has consequences in that the fish isn't utilizing the higher flows to get as far upstream as it can, and may end up getting stuck somewhere in the middle of the system, for example, as flows recede, and have to wait for another rain event in order to move further upstream. So with that said, just wanted to say that the report does have these 2-page summary sheets for all of the sites. That give the name and the location of the site, the type of site it is, some dimensions, and then gives the percent passage that for adults and steelhead, and the types of passage impediments that are at the site and the flows, along with a couple photos. So with that, I'm going to turn it back over to John to talk about scoring.
Thanks, Mike. Get my screen up here. Okay, so with those results and 30 sites, we felt it would be useful, and as part of our scope, to develop this scoring equation so that we could quantitatively compare passage and also some other factors across sites. So this is the scoring equation. Are you guys seeing all the, sorry, on a screen check here, are you guys seeing all the video, or you're just seeing the presentation on my screen? It's working, Lisa?
I just see a present. I don't see a video.
Great, thank you. So this is the scoring equation that we used. It has 4 metrics. We already talked in quite a bit of detail about adult passage and juvenile passage. The other two metrics, we have the relative distance to the next upstream barrier. So that is, if a site was remediated and passage was fixed or provided at that location, how far upstream then would the steelhead get before it encountered the next barrier? And in this case, we defined barrier as a site that provided less than 80% passage for adult steelhead. We also looked at the percent of the assessment reach downstream of the site, which is basically a measure of watershed position. When you're thinking about all of these barriers in context and sequence, it may make sense to focus on barriers lower in the watershed first and make sure fish are getting up before you fix the upper barriers. So that's a way to incorporate that into our scoring equation. All these metrics are normalized and expressed as a number ranging from 0 to 100. And then we have these weighting factors, these W's. The weighting factors are something that you can vary depending on how an individual organization, however the team would like to weight these metrics in terms of their relative importance. Also, the watershed position, I wanted to point out, is applied across all the other three metrics. So it doesn't get a weighting factor, but it's very important because we're basically crunching the numbers for the other three metrics and then adjusting for position in the watershed. And lastly, I wanted to say that the way this equation works, a lower score is equal to a greater benefit with remediation. So these are the weighting factors that we used. So you can see that adult passage was weighted very heavily. Part of the reason for that is, as Mike showed you, we only had a couple of sites that provided any passage for juveniles at all. So in the case of this set of assessment sites, juvenile passage isn't much of a differentiator. And we did have a lot of conversations both within our consultant team and with Valley Water about how to weight these different metrics. And what we found is, while there were some differences of opinion on the best way to weight the metrics, that within that range of difference, there was actually little effect on the relative scores that sites received. So in general, the scoring equation wasn't very sensitive to the range of weights that we considered. So another snapshot of a results table here, but now with some additional content in it. So you can see, for example, for site 1, the grade control at Vernon Avenue, the adult and juvenile percent passage, you can see the relative distance to the next upstream barrier, and then the percentage of the assessment reach downstream of the site is 21%. And this is actually the lowest assessment site in the study, but there are no fish passage impediments in the flood control channel downstream of here. So that site scored a 12. And what that can tell us here in terms of these relative scores is that there may be a lesser benefit with remediating that site than there is, site 2, but there might be a greater benefit with remediating that site relative to site 3. The next thing we did is we categorized the scores, and then this is something that Valley Water asked us to do. They found it useful that we could basically find some breakpoints, and we created 3 score categories: red, yellow, and green. This slide only shows red and yellow, and these shouldn't be confused with the green, gray, red passage analysis, the initial screening that Mike presented. These categories are based on our scores. And they're strictly based on the quantitative assessment scores that I just described. So you can see the scores on the right, and where we broke the categories out, so that you can take a closer look at that. It's in the report, including the green score categories. Looking at that visually here on a map, on the left is the entire study reach, and in the red box breakout on the right is the most downstream section of the reach. You can see that there's quite a few assessment sites in the lower reach. That's because of all the development in the lower reach. There's a lot of road crossings and grade control structures. We've got a mix of red, yellow, and green sites. And we have a high concentration of the red sites here, in part because of the weighting for sites lower in the watershed, and also the high number of anthropogenic features down here. So in this middle section, we have a smaller number of assessment sites, mostly green and one yellow. And then this is the uppermost section of our study area. And we had 2 sites, one green and one red. The Gaging Weir is the red site. And we're going to talk more about that in the discussion here. So the main takeaway here is that the quantitative results tell an incomplete story. The scoring equation is a really useful tool, but there are other factors that should be considered that we can't capture in this quantitative analysis, or that weren't part of this study. So the scores that we presented and that are in our report are based largely on the adult percent passage and the watershed position. What we'll cover here in this section is that the accuracy of the passage estimates that we developed varies, and that there's factors that are not accounted for in the quantitative analysis that will be important for prioritizing these sites for remediation. And we'll cover some of that in this section, with hopefully making the point that there are observations related to fish passage and protection that are not quantified in the analysis that should be considered when prioritizing the barriers for remediation. So the first example I wanted to talk about regarding the accuracy of the passage estimates is related to these Danielle fishways. The one on top is on Stevens Creek, and the bottom one is a Danielle fishway that was removed from San Francisco Creek, another Bay Area stream. And those of you who are familiar with these structures probably know that they're subject to frequent clogging. What happens is, as the flows come up, the woody debris can move with the high flows and it lodges in the structures. And it really has a big effect on passage through the structure. Not only that, but there's several confounding issues. One is that those same high flows that are moving the wood into the structure, they're also cueing the fish to migrate upstream. So as the wood's moving in, the fish are trying to move up, and then it can be really hard to get into the stream during the high flows to remove that wood. And if any heavy equipment or anything is required, it's likely prohibited by maintenance permits. So during the key periods when fish are trying to move upstream, it's possible that passage is less than the 70% suggested by our analysis, because the Heck-Raz model is modeling this in a clear condition, and we can't model the stochastic accumulation of debris. So before I move on, so in this case, the passage may be less than suggested by the analysis. And then this next example, the Gaging Weir, is sort of the opposite, where passage may be better than is suggested by the analysis. So this is the Gaging Weir near the most upstream of our assessment sites. And it's about a 2.5 foot drop here, which according to criteria is a complete barrier at all flows. It doesn't vary too much, that drop height at this location. But what we see here is there's this well concentrated nap right here. So the flow is well concentrated as it plunges over the weir, and that helps a steelhead down below line up its leap, and it's going to likely leap at the right spot to clear this because of the way the flow is concentrated. Also, there's a nice deep pool downstream of this weir. So a steelhead downstream would be able to get some momentum at an appropriate angle coming up from the deep part of the pool to clear this. And then there's a nice, safe and deep landing pool up top. It doesn't meet criteria under any flows, but a steelhead in good condition may be able to get over this barrier. And the other thing that should be considered and was not a part of our study is there's a 1/2 mile between this site and the big dam. And whether or not it's worth modifying a site like this would depend on the quality of the habitat upstream of this. How important would that habitat be to steelhead? And that isn't something that we looked at, but something that you probably would want to consider when deciding how to proceed, or if to proceed with modifications at this location. Another thing that isn't fully captured in our quantitative analysis is the relationship among the sites. Now, we did in that reach model captures some of the flow effects and depths and the way that the hydraulics, how they might influence each other. But that's a little different from what I'm going to talk about here, is how, passage at one site may then affect passage or passage opportunities at another site. So this is the grade control structure at Vernon Avenue, the most downstream of the assessment sites. We found this to be 73% passable for adults, but not passable until flows rise above 60 cubic feet per second to create adequate depth across this structure. Meanwhile, many of the upstream sites are passable at lower flows. So a steelhead moving into Stevens Creek may have to hold downstream of this structure until flows are adequate to pass, and it could reduce opportunities to pass other assessment sites or passage impediments upstream. This is another example of the relationships among sites that should really be considered during the prioritization study. There's two sites in this photograph. Site 17 is this culvert in the background. Site 16 is this boulder field in the foreground. Okay, and this little schematic at the bottom here. So imagine this steelhead here at a flow of 16 cubic feet per second swimming up through this boulder field, but it's not going to be able to get over and through this culvert because of shallow depths until flows rise to 63 cubic feet per second. So a fish might swim up towards the culvert, and there's really no good holding habitat in this boulder field. So it might swim up, try to get past, fail, get exhausted, fall back, and that might happen repeatedly until flows rise enough that the fish can get upstream and through the culvert. And the fish might, be injured, or all of these attempts might reduce its energy and fitness for moving further up at future assessment sites or fish passage impediments. So this is a case where, maybe you wouldn't fix the downstream site until you'd fix the upstream site, which is a little different from, for example, how the scoring equation works. Here's two sites that I wanted to talk about related to fish protection. So this on the top image is the Homestead Road crossing. It's at 85% passable for adults, which isn't so bad, but there's a lot of concrete rubble and sharp metal in the channel here. It creates these narrow chutes that a fish would have to swim through, and potentially causing injury. Additionally, there's crumbling concrete up on the banks that isn't captured in the HEC-RAS model and could continue to fall into the channel and affect passage at this site over time. This one on the bottom here is Sweet Oak Street, with 65% passable, and actually in the green category, driven in part there by its position in the watershed. What our analysis doesn't capture is this big hole here in this concrete apron. So as flows rise, a fish might be drawn to leap over here, and it could land right in that hole. So it may get stuck in the hole, it may get injured in the hole, it could fall back and have to repeat passage at this site again. So in conclusion, with the analysis that we're presenting here and the scores, passage, adult passage and watershed position are the key factors affecting those scores, but the scores and the categories work better for some sites than others, and not all the biological or habitat factors are accounted for. Additionally, there's other real-world considerations like land ownership, construction costs, things like that, that also need to go into an evaluation of next steps. So there's additional factors that should be considered. One of the cool things about the scoring equation is it could be adapted over time. Additional factors could be included as additional terms in the equation. And additionally, it could, the scores for these sites could be recalculated if barriers are removed. So because a lot of the way the equation works, the scores are relative. If a big important barrier were to come out over time as the creek is modified, the relative importance of any of these assessment sites could change, and the scores could be recalculated. Okay, we wanted to briefly acknowledge the staff that contributed to the study, both from Valley Water, Michael Love and Associates, and AECOM, especially Steve McNeely, Travis James, and Katie McLean on the consultant team. We're going to hand it over now for a minute to Kevin to talk about next steps. Let's see, Kevin, you probably don't need to take control of the slides here, so I'll leave this up and hand it over to you.
Okay, I think everyone can hear me. I also wanted to especially acknowledge some of the Valley Water staff that worked on this project, including Afshin Rouhani, James Manitakos, Jessica Lovering, Lisa Portella, Jason Nisajima, Clayton Leal, Leslie Lang, Chris Komlos, and Melissa Moore, who organized the consultant work that we're seeing today. You can see that the information presented is very quantitative, and it's one of the steps in trying to figure out how to move forward with the construction project eventually. And this is a complex system. I'm relatively new. 2 years ago, I was working on a bank improvement project that installed some redwood in Stevens Creek when the trail fell into the creek. And a year later after that, I started working with James and Afshin and Jessica. And specifically on this contract, James really led the way, and we had tremendous input from staff. So something I wanted to emphasize right off the bat is that, you know, Valley Water is really learning from the experience that we've had with Mike Love and John Stead. And we're becoming aware of how this analysis is done and how we can use it in the future to come up with prioritization, because there's a lot of intricacies in the creek. It's a very hardscaped creek. There's a dam upstream from it. There's a lot of important factors to consider other than just the sort of forensic approach with the hydraulic analysis. But this is a step in the direction towards a prioritization study. So to my scripted discussion, I hope you've all enjoyed the presentation. Thanks to our presenters who covered a lot of information today. For those of you seeking further details, we have a copy of the report which gets into it for you to download. And Jose mentioned where you can find that. So currently, our team is working with John and Mike to determine some basic fish passage options for the most critical 16 fish passage barriers that were determined by this analysis. And that's going to help us come up with a basic design concept, how much grade we need to overcome, what's the general nature of the fish passage barrier, relative costs, the complexity of the site. The next step will be for us to come up with a prioritization, and it'll be a group effort amongst John and Mike and all of our fish people at Valley Water. So what that will do is that'll eventually come up with a future design and construction projects is our goal. So in addition to the work that's been done with the general characterization of the creek and the identification of the 30 barriers and our top 16 for priority, when we get into the prioritization study, what we're going to look for is other engineering factors. For example, the access to the fish passage barrier. Some of them are extremely difficult to access because Stevens Creek is an incised channel and it's very narrow and deep. There's property ownership. Some of it's public and some of it's private. There's a presence of existing utilities. There's a Hetch Hetchy pipeline and other utilities near the creek or over the creek. We have to consider the maintenance work that would be required for any new structure that we put in. Challenges for permitting. For example, the overpass at the highway is a big permitting challenge, and overall construction and maintenance costs. So we'll be working on this prioritization study. We are working on it now. We'll continue into the spring, and we hope to have a draft of our report in the spring. Hopefully you can still hear me. It says my internet connection is unstable, so I'll try and speed this up. We're also going to update the PAD fish passage assessment database. And finally, we really expect that this whole process, which includes this general assessment and the site-specific investigations and the overall prioritization, will be useful as a template for similar creeks in Santa Clara with complex fish passage barriers. And one other comment is some of the abstract concepts that will go into the prioritization include, what if we have a big rainy season and there's high flows that change the configuration of the channel. It's a high energy creek, Stevens Creek. So we need to basically get a good look at the resulting work when we make decisions about moving forward. And then the other comment I would have is that if we do complete projects, we'll be able to update this report and basically the hydraulic models and the equations that we use to come up with our ranking for the report. We'll be able to understand how the report works. We'll be able to remove some of the projects that were completed and create new reports that are a living document moving forward. So with that, I think, Jose, are you going to take us into question and answer?
Yes, I am. But now we're going to go into the Q&A portion. If anyone has questions, just raise your hand and I will recognize you. And we will go from there. However, we do have 2 questions that we received in the Q&A box. The first one is for John. And the question is from Rajiv. The question is, was the barrier in Cupertino a deep cliff golf course not included in the study?
Let's see. I'm not sure I can answer that off the top of my head. I can pull up a list of sites and here's all the sites that we included. None of them are flagged with the name Deep Cliff Golf Course. I'm not sure if the person asking the question could place that where that would lie on here. It may be one of these sites. Mike, do you know of a site that might be the site mentioned by the question there?
I do not. I know where the golf course is. I believe we walked some of that in Valley Water, walked other sections, but
Yeah.
I'm not sure if it was one that's been remediated or not. So it's a good question to follow up on.
Yeah. So this strikes my memory. I recognize this, and it may be as part of my conversation with Rajiv in the past, but I can look into this and get back to you, Rajiv, to see if to figure out if there's a corresponding site located in the report relating to that spot.
And I did see a comment on the chat that says that it's actually upstream of our Gaging Weir. So it's upstream of that.
Oh, okay. So it's out of the project range.
We did stop at the Gaging Weir.
So the answer would be no.
Well, I don't know. Kevin, I think it's worth a closer look and something maybe we could follow up on, because I think the Valley Water Reconnaissance did go from the Gaging Weir up to the dam, right? Well, actually, we've had a number of folks. Maybe
yeah,
Jessica.
We did look upstream, and the Deep Cliff is would be down. I believe it's downstream from the Gaging Weir. So I'm not quite sure. Well, we can look at there. We did find one at Blackberry Farm, which is a little bit, is very close to that. I'm not sure if that's the one they're talking about. That's very, almost adjacent to Deep Cliff Golf Course. So that may be it, but we'd have to look at some more.
Yeah, there's also been some work in that reach and some projects as well. So
yeah,
I think
one site that was remediated by the city of Cupertino, I believe.
With
Mount had been remediated, it turned into a roughened channel.
Yeah, with a more precise location, I think we could follow up on that and give a more precise answer.
Rajiv did indicate that it's currently in remediation. And I got a comment back from Mr. McNeely saying Jim is correct, Blackberry Farm site at the golf course. So, all right, we have a hand that is being raised, and let me recognize that individual so that we can see a hand being raised. Oh, here we go. McNeely, I'm gonna go ahead and unmute you. Go ahead and unmute yourself so you can proceed to ask your question.
Sorry, I did it in the Q&A there. I believe Jim is correct, and the Blackberry Farm Boulder Weirs, that site is at the golf course.
Okay, and that was the site that I think the site that we evaluated, it was a couple of rock weirs that looked like they had been installed as a either grade control or maybe to replace some grade control, but we're probably with fish passage in mind. And
yeah, that's correct, John. That's a balanced hydrologics project for the city of Cupertino.
Mm-hmm. So we took a look at it, but it measured up pretty well.
Great. Now we'd like to move over to a question that we received in the Q&A box from Ross. I'll start out. I'll read it out. This is really great, summarizing the fish passage barriers to successful reproducing for steelhead, but there are other barriers to their survival. Will there be further evaluation? I'm thinking of turbidity and deoxygenation of the water coming out of the dam. Also, water temperature. This would be a good capture in the same place. Sounds like it's a question for John.
I think I can answer that. So we're in the planning stage now. This is like early planning. We've assessed the creek. We're looking at the hardscape right now. We're looking at the basic physics of hydraulics in the channel. The next step will be to sort of add a layer of prioritization to the ranking that came out of the report. So it's going to include a lot of different factors, the interconnectedness of the different passage barriers, location, the constraints to construction. And I think at that point, once you start getting into more of the planning study, we would definitely define the problem, and the problem would be more than just the hardscape. It would include the water quality issues that are related to the creek. So when we get into a full-blown planning study, which has a problem definition and conceptual alternatives, and then a planning study report which recommends an alternative, we would definitely consider those factors.
I just wanted to add to Kevin's response, which is correct, that comes later in a later phase of the study, but also to add that our water quality staff have already initiated water quality monitoring downstream of the reservoir, including DO. So I can provide more information on that study to the question in response to that question if required.
Okay, so we currently don't have any questions in the Q&A box or anyone raising their hand. So I'm wondering if any of the attendees have further questions. Maybe in the meantime, if I don't know if John, Mike, or Kevin have anything else you want to share regarding the presentation, any interesting findings or anything that maybe you didn't cover that you'd like to share with attendees that would be of interest to folks?
Just briefly, Jose, I did want to mention, I did sort of forget to mention early in the introduction that the overall framework within which this study was conducted, with the exception of the scoring equation, everything leading up to that is more or less following the approach laid out in the California Salmon Stream Habitat Restoration Manual, Part 9, Fish Passage Evaluation at Stream Crossings. So, there's, as Mike went over, there's some deviations and adaptations to that overall methodology, but that is the framework within which the study was conducted.
We did receive a question from Ross. The question reads, what is the timeline for next steps?
Right. So we are basically currently working on this prioritization study, and we're looking at getting a draft done in the spring of next year. And then from that, I think we would move into, once we have an idea, we're basically strategically locating projects to take into a planning study. There's too many right now to do all 30 locations for a planning study. And effectively what we're doing is we're moving towards a planning study that will result in a recommendation for a design and construction project. So we've whittled this down to 16 projects, and we're going to look at those carefully in the prioritization study. And then once we have a prioritization, we'll move into a full-blown planning study, is my understanding.
Do we have any more questions from attendees? Any comments that they like to put into the Q&A box, or verbally ask a question? Another question here. The question is from Rajiv. The question reads, is upstream travel the only concern? Can we assume if upstream travel is uninterrupted, there won't be any issues with travel back to the bay?
Yeah, that's right. If they can get up, they can get back down, and landlocked populations will even move down, through massive reservoirs and huge spillways. So there's really nothing in Stevens Creek, downstream of Stevens Creek Reservoir, that would prevent a fish from moving downstream, as long as there's some flow.
I guess I'll speak up on this mic here. The one place that maybe would have issues would be the two Daniil fish ladders. And I'm thinking of a more runbacks or kelts. These are adult steelheads going back to the bay, and they would be hesitant to go down the ladder, so they would have to go down the concrete slip and slide, which is the drop structure. And so that does have some limitations, since the depth over that is quite shallow often.
Yeah, that's a good point, Mike. And so that's something else that isn't captured in our analysis, another consideration for those Daniil structures.
So we still have time to take more questions from attendees. There's more questions where they like to submit or to verbally ask. But maybe in the meantime, John or Mike, are there any, given that you've worked on several projects, any examples of successful projects where such work has been undertaken and the results, were successful?
Yeah, there are, Jose, there's a lot of examples. Actually, I had showed a picture of one that's maybe a good relevant example, but there was a small diversion structure on San Francisco Creek, so a nearby watershed, where passage was provided via this Daniil fishway here. And I think last year we completed a project for Stanford University. They took out this diversion structure and this fishway and replaced it with riffles and pools. So overall improvement to passage at that location. But yeah, there's so many examples. Mike, are there any that you want to highlight? Oh, you just went on mute, Mike.
No, I think, there are a lot of examples around the bay, as well as obviously across the state, where small streams and rivers had runs restored through doing these types of remediations to barriers.
I could elaborate too on, regarding the next steps. One of the things that AECOM and Michael Love and Associates are working on now is for those top 16 sites, we're coming up with some options for fish passage. So it's, based on the stream profile and the grade that needs to be recovered through each reach. We're trying to come up with some options, approaches, and lengths of projects, things like that, that will help Valley Water consider, how they would approach a construction project at each of the top 16 assessment sites. And that's a little different from like an alternative study. So the idea is to provide at a lower level of effort some information to inform the prioritization, but not necessarily to replace an alternative study and some more detailed analysis that would be needed at those sites that are prioritized highly and then do require additional study to identify the most suitable design.
We received a question from Mark. The question reads, after you enter the data into the PAD, it would be interesting to run the barriers in FishPass, and provided a website here. And this is to see how the prioritization there compares to what the report came up with.
FishPass is something actually when we first planned this work, we were watching FishPass really closely and wondering if it would be a tool that we could use for this study. But, although we got a little ahead of FishPass, so we weren't able to use it, but it is interesting. And I know Mike's been following the development of FishPass really closely. You might have some thoughts on that.
And yeah, I think it would be good to do that and informative. And I think also the next steps that we're taking right now, which is kind of look at what may be the scale and ultimately the Valley Water will look at the cost of remediating each one of these sites at this high level. But that's kind of what we're doing now. And that actually is one of the very important factors that go into FishPass is kind of what the cost for remediation is. So we'll have a little better idea, I think, of what that cost is to be able to put into that prioritization model.
Great, thank you. We received another question from Marianne. The question is there much future proofing going on, for example, with flow assessment regarding the likelihood of worsening drought due to climate change in the coming years?
I can't say that our analysis addresses climate change, or it's it's really a hydraulic and fish based on hydraulics and fish swimming abilities. I'm not sure Valley Water may have some thoughts on climate change kind of at a more programmatic level for Stevens Creek or for their streams.
Yeah, I would say we definitely have staff looking at climate change and how it affects sea level rise and extreme rainfall events. We have staff that are dedicated to that. I'm not working on it in particular, but I know that Valley Water is concerned about climate change. And you can probably find information on our website, valleywater.org, if you look into it, or if you have a specific question, you could send it to me, and I can look for resources for you.
Actually, we are just launching a public input survey on our climate change action plan. So I believe that we're hoping to go live with that in the next week or two. So Valley Water since 2017 has been internally developing a comprehensive plan to address sea level rise, fluvial flooding, and other impacts of climate change. And it's all contained in this climate change action plan. So good question and timely. And look out for the study that we're pushing out to all of our stakeholders and community groups.
Just got a response back from Marianne saying thank you for the info. Do we have any more questions from attendees that they would like to submit to the Q&A box or to raise their hands for staff to address? Oh, we just got a question here from John. Is there any consideration for reintroduction of steelhead above the reservoir?
I don't have an answer for that. I'm not certain. I'm relatively new to Stevens Creek, but this study was basically to just below the dam, so I'm not sure of upstream. We do have staff that can answer that question, so if somebody wants to submit that question, I can circulate it.
Great. For the question. See, still have time for another for one or two more questions. If the attendees would like to ask any more questions. And I am going to go ahead. And once again, I'm going to put a link to where the study is located, and the presentation will be uploaded shortly after we end the presentation today, as well as the video of the meeting. And then as we continue to move forward with this project, we'll continue to update that webpage as well with any details as we proceed with efforts. Any more questions? I think, Lisa, that might be it for the Q&A period. So I guess we will turn it back to you.
Okay, well, thank you, Jose, and all of our presenters. Really interesting presentation, really challenging work. I just am so excited that we've completed this portion of the study, having, trained up our staff as well in this methodology for looking at barriers, and just really looking forward to the next steps of getting some concept designs or pre-design, looking at how we could address these barriers or work with partners to address these barriers in the future. So I also wanted to remind everyone that Valley Water has a really extensive fisheries monitoring program. We've recently expanded it even more, and information is available on our website regarding that. If you have further questions about this fish passage study or other, fisheries questions, Stevens Creek or others, I'm going to direct you to Kevin, I suppose, who could then maybe circulate in relevant staff and get an answer back to you. So thank you again for joining, and enjoy the rest of your day.
Thank you.
Thank you, everyone, for joining us.